Here we go, the last quiz that you have to make up for this school year. Colligative properties and dilution. So, colligative properties is the properties of different solution, depend on their concentration. You know, when we have, for example, sugar water, salty water, right? So, the more salt you put into the water, the more concentrated it makes, right? So actually you're adding to water. The salt is impure to relate to water. So the more impurity inside the solution, the higher the boiling point. Because if you just think about water, water melts at 0 degree, right? This is the melting point. And then it boils at 100 degree Celsius. It's boiling point. So the more impure of the solution, the lower the melting point, the higher the boiling point. So the boiling point is up there, so it will make it higher. The melting point is down there, so it will make it lower. Just remember that, okay? And dilution, we have equation M1 V1 equal M2 V2. M is molarity. V is volume in liter of the solution. And M2 is new molarity, and V2 is new volume of solution. Okay? Just remember that, and then we're going to work our problems. Very straightforward. First, colligative property is a property that is dependent only on the number of solvent particles present in solution, which is true. Which is not true. My bad. Which is false because colligative properties is property depend on the number of solute particle present in solution. Okay? So it's false. Which will freeze faster? 0.5 molarity solution of salt water or pure water. So, first of all, which one has higher concentration? Or which one is more impure? Obviously, compared to pure water, this is more impure, right? So it will have higher boiling point and then lower melting point. Okay, if it has lower melting point, because we are talking about freezing, if it has lower melting point means when you reach lower temperature, it will freeze, right? So which one gonna freeze faster? The higher temperature, like for example, 0 degree is the temperature for pure water. So if 0.5 molarity solution has lower melting point, I would just assume it will need a -5 degree. Which one gonna freeze faster? 0 degree. Because it's faster to reach 0 than reach -5 degree, right? So your answer is pure water. And next, which will freeze faster? This time, you're freezing faster. Oh, it's the same thing. If you want to freeze faster, the lighter impure would go faster, okay? This is more impure, so it will freeze slower. If my question is not freeze, if my question is boil faster, same answer. Because when you have less impurity, it's just easier to reach the boiling point and the melting point, or the freezing point. Okay, so it would be the same answer. And next, when salt is added to the road, the concentration obviously increase because more salt add to it, so it's more concentrated. So when the concentration increase, the lower point, which is the melting point, go lower. The boiling point, which is the higher point, go higher. So this one asks you about freezing point, which is the same as melting point. The lower point, freezing point, will go lower, so decrease. Okay. Next, dilution is the process of adding solute to a solution to lower the concentration of the solution, which is wrong. Reason why is because dilution is the process of adding solvent. Just like if you want to make sweet tea less sweet, what do you add? You don't add more sugar, you add more tea, right? So tea is what you dissolve the sugar in, which is a solvent. Okay, so dilution is a process of adding solvent. And also, when you dilute something, the solute never change, which means if you're diluting the sugar water or sweet tea in there, the amount of sugar in the tea never change because you're only adding more unsweet tea to dilute the sweet tea, right? You're not adding more sugar. So the sugar amount never change. The solute amount never change. Okay, next. How will adding 50 ml of water to a 0.1 molarity solution of the sweet tea affect its boiling point and freezing point? So you're adding more water. Water is what? Water is solvent. Okay? So you're adding more water means you are diluting the solution. So means you're making the solution less concentrate. Right? Or less impure. So that will means it will make the boiling point, the high point, lower, the low point higher. Okay? So boiling point lower and the freezing point higher. Vice versa. If the question I tell you I'm adding 50 gram or ml of sugar to the sweet tea. So if I'm adding more sugar, I'm making it more concentrated. Right? So more concentration will make the higher point, which is boiling point, go higher. The freezing point, which is lower point, go lower. Okay? So make sure you read the question carefully. The question is not going to be exactly the same as this one, just tiny bit twist. So I'm telling you the twist. If you don't get it, just come back to the video and review it. Okay, during dilution process, which of the following amount of solution does not change? What does not change during dilution? Always solute does not change. Okay? What change? Solvent change, solution change, concentration all changed. Okay, calculation. If 30 ml of water is added to 200 ml of 0.45 molarity potassium sulfate solution, what will the molarity of the diluted solution? So remember, first we have to have our given, right? Or you can write your formula. Our formula is M1V1 equal M2V2. So we do have our information of molarity and volume before the dilution. So what is the molarity of the original solution? Original is 200 ml and 0.45 molarity. So 0.45 times 200 equal, what was the new molarity? So M2 is what we're looking for. M2 times, this is, V here is volume of solution. Okay? Solution means total amount of liquid together. So you are adding 30 ml of water to the original 200 ml. So our final volume of solution after you add extra stuff will be these two add up together, right? So 200 plus 30. Okay, now you just do the algebra. So M2 equal 90 divided by 230. 0.39 molarity is your new solution. And you can self-check. If you're adding more solvent, like this case, you're making less concentration. The answer must be less than 0.45, right? And then depend how much less you added in. You can use elimination. If you're adding more solute, instead of adding water, you're adding more potassium sulfate. The concentration of new solution will be higher, definitely, right? Okay, next. How much 0.7 molarity sodium chloride solution can be made by diluting 400 ml of A molarity sodium chloride? So, same formula, M1 V1 equal M2 V2. Our original is this, right? Our original volume is 400 ml of 8 molarity. Molarity is 8 times 400 equal, our new solution is given to you. Molarity is 0.7. 0.7 times how much we're looking for the volume of new solution, V2. So divide by 0.7 on both sides. V2 equal 8 times 400 divided by 0.7. 4,571. Answer is the first one. All right. Our last question. How much 0.05 molarity hydrochloride solution can be made by diluting 200 ml, 250 ml of 10 molarity hydrochloric acid? Okay. Our same idea as before. M1 V1 equal M2 V2. Original solution, 10 molarity times original volume, 250 equal new molarity 0.05 times new volume you're looking for. Both sides divided by 0.05, 0.05, and use a calculator. 250 times 10 divided by 0.05 is 50,000, which is this one. All right, that's the end of your makeup quiz review, and good luck.